So, after a little bit of a detour, I still hope the point is obvious. 18 gauge, which is a decent wire size, still isn't near enough to transport power for like 32 feet or even 16 feet, so 5 meters or, yeah. Okay, so we have plus and minus hooked up just like we had before. No, we're not going to blow some strips. Please don't. I just got these bars made. Let's run it real quick without power going to it. Because the board should auto-adapt, and this little board even should also auto-adapt. But let's put that to the test. Okay. This all looks good. Minus, plus, and the input wires here are disconnected. Yeah, should be fine. Pew. Okay, so QuinLED is turning on. The data booster is also turning on. Yes, the data booster has been designed up to 48 volts. And let's see if WLED is online. Yes, it is. Okay, so far so good. That's a nice thing about these new boards. They auto-adapt to the voltage that's coming in, even to 24 volt. So, we now take our power wires. No smoke. Aww. And, well, let's adapt them to 5 volt. Should we start with the smallest converter and see if it can handle the load? I think that's fun. So that would be this one. This one's definitely the tiniest. Okay, so this side says input. So I guess I'll connect red here. And black here. And then I take these red and black. Connect those here. Connect those here. And then we have the same on the other side, and those can go here. So blue for ground, and then yellow for, which should now be 5 volt. So a downside you can already see, this is becoming a mess. But yeah, you maybe have to hide it in a project box or something like that. Okay, let's go. Okay. We have LEDs. Interesting. Does that just work? Let's get my amp meter here again, and I guess it should be on this one. Right. So let's compare that to what we had initially. 24 volt tiny 5A converter. We have to go to full power. Orange 100%. It's drawing 14.5 watt from the socket, so it's actually drawing more than it initially did. And the amp meter is showing 1.45, let's say. That's slightly lower than we saw with the direct short wire connection, but yeah, it's okay, I guess. Well, I guess let's go for broke, huh? 100% white. Yeah, let's see if we can handle it. In theory, it's above what it can handle. Oh. Okay, well, it's bright for sure. It's much brighter than it was last time with just a 5 volt. It's drawing 43.5 watt from the socket, and the amp meter is seeing 5.2 amps. Can you see the amp meter? Yes. Cool. Okay, let's splice the voltage meter in there too. Trying to make this somewhat work. Oh, it's outputting a stable 5 volt. Cool. Okay, so as we can see here, The voltage we're seeing going to the LEDs is 5.1 volts and stable. That's actually pretty good. Yeah, well, I imagine it's heating up. So far, it's not even lukewarm. Cool. So instead of measuring what's going to the LEDs, let's measure what's going to the data converter and then to the board. Yeah, because the cables only need to do 0.7 amps now. So that's a whole lot less than the 6 amps. But because it's 24 volt, well, it only has to transport a whole lot less. So, yeah, that works. I could flare the converter, but the converter is in a metal case, so that won't really work on the FLIR. I could put some tape on it, and then we could measure it, but basically I'm taping up a part of its heatsink, so taking away the ability to dissipate heat. But yeah, put pink tape on it. I don't have pink tape. It's an oversight on my part. I apologize. Let's see what the black underside is. Oh, I think we can see where the... Ow. Okay, it's getting hot. I think we can see where the buck converter is actually located, if you see here. So this is 64. Ow, okay. The paper burns better too. Thanks, guys. Yeah, it's warm now. Okay, let's turn that off. Because, well, I have multiple converters that I wanted to test. Okay, so I have a second 5 amp converter from the same, they're all from the same AliExpress seller. So this XWST. My camera screen is a bit overcrowded because of certain wire lengths. Okay. There, we'll make that work. Okay, so now we're testing this guy. Okay. LEDs still turn on, that's good. Let's just go to full white. Oh, wow. Oh, that's definitely more than the other one. Slight voltage drop, but I'd say 4.9 volts, okay? So before we had white 100% 43 watts and then 5.2 amps going to the LEDs. And this one is outputting 6 amps to the LEDs. So that's better. So I guess it's more efficient. Yeah. The previous one was a 5 amp converter, but this is officially also a 5 amp converter, but it's outputting 6 amps. Oh, there's some hot... Oh, okay. Maybe I'll get the FLIR now. There's some hot spots there. I know you can't really see on camera, but that little spot there is 80 degrees. Yes, asking 6 amps of this guy is probably not gonna give it a long life. The back side is 46 degrees. Uh-oh. It's now 89 degrees. This isn't looking too well for this little meter, or for this little converter here. Or rather, I liked the small one being current limited, but not overheating like I feel this one's going to. That's a better design than just drawing whatever. 94.5. Yeah, well, I wouldn't want to run a converter that is 94.5 degrees at some point. That just means there isn't enough heat sinking. But then again, it's doing 6 amps. So, I mean, if you use it for 3 to 4 amps, it's likely fine. But right now, it's just being over-asked. No, I don't want to pour water on it. Although it's water sealed, but yeah. What I want to do is turn it off and connect the 10 amp version of the same thing. And again, if you're doing a middle type style of injection, so let's say you have 600 LEDs. Oh, wow. Look at the 10 amp version versus the 5 amp version. The wire thickness is definitely different. Can you see that? It's easily twice as thick. No, well, if you're talking a middle type of injection, this is a nominal load. 5 to 6 amps is not that much if you're running 5 volt LEDs and it's in the middle of the strip, basically. Or in the middle of 2 strips, I'd say. But that's exactly where you'd want to use this thing. So, oh, wow. This one's outputting 5.2 volts. It's a bit high. It's okay. It's on the high side. It's still okay. That's generally within spec. Okay. Let's go to 100%. Let's just do immediate 100% white. Okay, dropped a little bit in voltage. Let's say plastic 10 amp converter. Cool. And it's outputting a little bit higher voltage. So higher voltage combined with higher amperage is, well, a lot more power for your LEDs. So this is definitely, in my opinion, a different converter than in the other block. Although visually they might look the same. I mean, just even these cables here. See that? That's a massive difference. Right, so the 10 amp one is $6.40, and then it adds some shipping. Oh yeah, and the shipping, well, okay, if you buy 4, the shipping is less than just adding up. But the 5 amp one was, yeah, so $5.19 or $6.40. I'd always get the 10 amp one because that's already doing a lot better. And did they have another variant? No, okay, so that's the biggest, the highest amperage variant they have in a plastic form factor. There we go. So there's a little hotspot here, 43, 44, 46. Oh, there's a chip there. 50 degrees. Yep, 50 degrees. Well, voltage is pretty stable and good too. And the amps, 6.1 amp, that's still doing well. Yeah, I like it. And, well, if we look what is actually going to the converter, we're seeing 1.36 amps because, well, that is 24 volt. And the 6 amps is at 5 volt. But now the 5 volt cables are very short, so that's no longer a problem. And these are 18 gauge cables, and they can transport 1.34 or 1.4 amps over the 10 meters or 32 feet we're currently doing. So it's going to be the question of, can I hide these extra wires where I want to make injection points? And then how much would really thick cable be, you know, like a 12 gauge like we looked at that we needed, versus buying a little converter and then using 20 or 18 gauge cable, we're using 18 gauge today, to go to the LEDs. I mean, yeah. 20 amps or bust! Well, I can hook up another bar. Yes. Okay, you can't see it. Maybe you can. Now we have 2 orange bars. Okay. We're doing 1.88 amps. No, yeah, 1.88. And we're looking at 14.7 drawn from the socket. Let's immediately go for broke. Let's go for white 50%. That is asking 42 watts from the socket or 6.3 watts from the converter, which you can't see anymore. There we go. And now let's go full power. Okay, we're asking 84 watts from the socket. I'm going blind. And let's see here. The meter is showing 12.18 amps. Oh no. Are we going to get fired this stream instead of the previous one? Okay, well, we're doing the 12 amp on a 10 amp converter test. That's always good. Yeah, you can't say I'm not a people pleaser. So even doing 12 amps, it's still providing 5.1 volts. That's pretty good. So this one is showing a hotspot over here, and that is 78 degrees right now, 79. Let's see on the side. Ow, that's burning my finger. Okay, that's 84, 86, 87 degrees. And then on this side, 90. Yeah, 90, 90.4, 91. Okay, and then on the bottom side, well, we can see where the hotspot is. That is 103 degrees. Yeah, so asking 12 amps from this 10 amp converter for a prolonged period, because it's still doing 12 volts, 12 amps, and, well, the voltage, let's see real quick, 5.14 volt. So, it's a little champ, and I'm going to turn it off now. Because I don't want it actually to burn. Okay, so, yeah, I like this one. These converters are, I mean, come on. This one is a bit bigger, right? Sure. Let's do that. Looks good. Do it. We have orange light. Let's immediately go to white and to full power. Okay, we're drawing 80.4 watts from the socket. Let's write that into a little document here. Metal 15A converter, white 100%. Oh wait, that's with 2 bars. Wait, hold on. Okay, 41. Yeah, 41 watts. Okay, and 6.12 amps. Okay, so the metal one and the plastic one seem to be doing about the same. Yeah. Okay. Let me plug that back in again to give it some load. There we go. And now it's doing 80 watts and 12 amps. Yeah. Okay, that's a very nice 5.1 volt. That's very tidy. So in general, I think these metal ones will always be more suited than the plastic ones. So the plastic ones, even the 10 amp one, was $6.40. And here you can see they have a lot of different variants. Again, plastic 5 amps. Oh, this one's actually more expensive. Interesting. Oh, here's the 5 amp aluminium one we looked at first. That is about $10. Oh, and this one has free shipping. Okay, yeah, that makes sense. And what's this one? 3 amps. Okay, so they have a 10 amp aluminium one. They have a 15 amp aluminium one, which is the one we're currently testing. And then you can step that up to 20 amp, 30 amp, and 40 amp even. But remember, you can only inject so many amps into one spot of an LED strip. So even the 15 amps is kind of overkill, because even if you have 2 times 300 LEDs and you're in the middle of that, at most you'll inject maybe 8 to 10 amps at peak. And really nothing more than that, because the strip can't take in more power at that point. You'll have to inject at multiple points to basically feed that power into the strip. But then you could maybe take like a few of those 5 amp or 10 amp plastic ones and feed those at the edges of the strip, and then take one of this 15 amp one and do that in the middle, so you have a little bit of overhead on all of them basically. But yeah, 40 amps is expensive, but you really won't need that. The 10 amp or the 15 amp don't really differ that much, so I just get the 15 amp. That's performing like a champ here, because it's still doing 12 amps, no problem. And yeah, how hot is the quad and the fuse? Well, not very hot, because the quad is getting, can you see that? Yeah, 2.83 amps. So the fuse is also only getting 2.83 amps. So that's not a lot. So the fuse is fine, because that's 24 volts, and only after this guy does it become 5 volts. Yeah, this still, I can feel that it's heated up maybe a little bit, but nothing really to speak about. In the end, we were able to test the 24 volt versus the 5 volt, and we saw that we can definitely get about the same amount of amps being used using some of the converters. So the LEDs would have the same power, but then we can use much shorter, much thinner cables than we were able to do without using the 24 volt, and thus save a lot in cable, or cable hassle actually, and also in money probably in the end if you're doing a really big project. At some other point we'll look into if you're running 600 or 900 LEDs and you want to run multiple of these boosters. Let me actually show you. I did actually prepare for that because this is another 3 of those 15 amp units. What would happen if you'd run multiple of those boosters over those 900 LEDs, let's say, and can you create a 24 volt distribution network and 5 volt LEDs? So that will be for another day.